Consider the limit as x approaches 0 of x squared times the cosine of 1 over x squared. So for this kind of a limit, we maybe could try and use one of the limit laws. We have a limit law that says the limit as x approaches a of a function f of x times a function g of x equals the limit as x approaches a of f of x times the limit as x approaches a of g of x. So applied to this limit, that would say that we could rewrite this as the limit as x approaches 0 of x squared times the limit as x approaches 0 of cosine of 1 over x squared. And since this limit is 0 and this limit does not exist, we could say overall that the limit as x approaches 0 of x squared times the cosine of 1 over x squared does not exist. But there's a problem. This is incorrect. Remember that the limit laws only worked if each of these individual limits existed. In other words, if the limit as x approaches a of f of x existed and the limit as x approaches a of g of x existed. In this case, the first limit as x approaches 0 of x squared, that does exist, it equals 0. But the second limit does not exist, so this limit law does not actually apply, and we need to try and find another way to tackle this limit. Okay, so let's try something else. So first note that cosine is a trigonometric function that oscillates back and forth between -1 and 1. And that means that the cosine of 1 over x squared also oscillates between -1 and 1. In other words, it doesn't really matter what we place inside this cosine here. As long as we have an amplitude here of 1, this is going to oscillate back and forth between -1 and 1. You know the graph, it goes back and forth, back and forth. Well, now I could multiply through by x squared. X squared is going to be a positive number, or 0 at the worst, if x is 0. So I don't have to switch the direction of the inequality. And now I'm going to notice something that is going to be known as the Squeeze Theorem. So first I'm going to look at the left-hand side here, the negative x squared, and I'm going to take the limit as x approaches 0 of that. And I get 0, that's a very easy limit. And I'm going to look at the right-hand side, look at the limit of that. The limit as x approaches 0 of x squared, and that's 0. And both of these things are going to allow me to conclude that the limit of the thing in the middle also has to be 0. And this is an example of the Squeeze Theorem. If we look at this graphically, here is a graph that shows in red the function x squared, and in blue is the function negative x squared, and then you can see in green the function we're interested in and how it's kind of trapped in between here. It's squeezed in between the other two functions right near 0. And so because of that property, that's what allows us to use the Squeeze Theorem to solve limits like this. So what is the Squeeze Theorem? So Squeeze Theorem says, suppose f, g, and h are functions such that f of x is less than or equal to g of x, which is less than or equal to h of x when x is near a. And I should point out that at a, this doesn't need to be true. In fact, in the previous problem, we saw that g of a was not even defined. We're just talking about when x is near a. Then, if the limit as x approaches a of f of x equals the limit as x approaches a of h of x, and we'll call that L, those are the outside functions here. That would be the f on the outside and the h on the outside. Then the limit of the function in the middle, the g of x, as x approaches a, also has to be L. And you might see some other names for the Squeeze Theorem, such as the Sandwich Theorem or the Pinching Theorem, or my favorite, the Two Policemen and a Drunk Theorem. But all of these pertain to the same idea of taking a function and sandwiching it or squeezing it between two other functions, and then if the limit of the outside functions are the same, then the limit of the inside function also has to be equal to that. So let's look at one more example here. So you might have noticed, here's the Squeeze Theorem again, you might have noticed that a good place to start with the Squeeze Theorem is to look at these trig functions, sine and cosine. They both oscillate between -1 and 1. So if you see a weird looking limit to solve that has some kind of crazy sine or cosine in it, that might be a good place to use the Squeeze Theorem. So for example, how about the limit as x approaches 0 of x squared times the sine of 1 over x? So again, we can do a similar thing here. We can trap the sine of 1 over x between -1 and 1, multiply through by x squared, and we don't have to change the direction of the inequality because x squared here will never be negative. And then we take the limit of the outside things. That would be the negative x squared and the x squared, and they both equal 0. Therefore, the limit of the inside thing, x squared times sine of 1 over x, also has to be 0.